Right, here we are at the top of page 2 for 4.5. On the bottom of page 1, we had two problems just like this where we walked through given a slope and a point, and the instructions ask you to write, let me recopy those so that you have them. Okay, so you're going to write the point slope form of the equation. So there's your first answer. Then use it to write the slope-intercept form. So we're going to do both of these as a try here. You've got your number 6 and then you've got your what if. We'll also do this one as a try. But let's take them one at a time. So number 6, you can mimic what you saw on page 1. Go ahead and pause the video right now and come back for the answer. Or you can keep the video playing for another couple seconds because I'm going to reveal a hint for you. So process. Okay, here's the hint. So hit pause if you haven't, if you don't want to hit and want to try it on your own. When you're doing these type of problems, look to see what's been given to you. In this case, the slope and a point have been given to you. You're going to start by plugging those givens into point slope form. Okay, I would suggest writing it out before you start plugging things in. Write it and say it so you get the point slope form memorized. Okay, once you get point slope form, then you're going to rearrange to slope intercept form, which means that you're going to solve for y. Okay, all right, now hit pause, come back to reveal the answer. Okay, and first of all, the point slope form of the equation would look like this. Y plus 2 is equal to -4 times x plus 5. If your signs are off here, remember that the formula is minus the coordinate, so it's y minus the -2, which gives you a plus, and it's x minus the x point, so it's x minus a -5, so it's plus. Once you rearrange that to slope-intercept form, distribute, and then move the 2, you would end up with y is equal to -4x minus 22. Notice that the slope, just like they show up as m in both equations, it remains the same, -4. What changes is the point that we get to see. Here we get to see a point on the line, nothing too special about it, just the fact that they gave it to us at the beginning. Here we get to see the y-intercept. It crosses the y-axis at -22. So that's what happens when you rearrange it to slope-intercept form. Okay, now I'd like you to try this one, the what if. It looks like this, so that means there's something slightly different about what they're giving you here. What we've seen so far is they're giving us a point and a slope. We're able to put that into point slope form, rearrange it to slope intercept. So slightly different, pushing you just a little bit here, but not different in the sense of our steps. Our steps are going to stay the same. So try that, hit pause, come back for the answer. Okay. So the point slope form, there's two answers that they're looking for here. The point slope form would look like this. Y minus 0 is equal to 1/3 x minus 0. Where'd the zeros come from? Well, the origin is the point 0, 0. So there's your x1 and y1. And point slope form shows that. It shows the y minus the x and the x minus, or y minus the y coordinate and x minus the x coordinate. So you want to keep that looking like that. And then the slope-intercept form of the equation, again, they're asking for two answers here. You distribute that 1/3 and move the x over, or the 0 over, or really it would just go away, right? Y equals 1/3 x would be our slope-intercept form of the equation. Okay, so this point slope form, we've talked about that this is kind of our fallback plan when we don't have the intercept, we don't see the graph, but we're asked to create the equation of it. So it's like our midway step to getting to this. On the exam, we're going to get to the point where I'll say, hey, here's a slope, here's any old point, come up with the slope-intercept form of the equation. You'll want to bring to the problem, oh yeah, I need to use my fallback plan of the point-slope form to put it in there, then rearrange to get this. So the book is walking you through it right now. You need to get to the point where you know that the point-slope form is your fallback plan. Okay? So it comes in very handy when they give you slope and any old point. Okay? So given slope and any old point, you'd use point slope form. Okay, that's when you use it. But it also comes in very handy when all you've been given is 2 points. I think my pen is about to run out here. Let me see if I can fix that. How sad. Okay, that one went quick. The life of my little blue pen is over. Sad. We'll move on to the next one. It also comes in handy, very handy, when all you have is 2 points. They don't even start by giving you a slope. They just give you 2 points on the line. And what we want, in other words, we don't have slope to begin with, to start with. Okay, all we have are 2 points on the line. We have some sort of x1, y1, and x2, y2. Okay, first point and second point. And these would be numbers here. What we want is to have slope in a point so that we can plug it into y minus y1 equals m times x minus x1, so that we can plug it into point slope form, and then from there take it to wherever we want. Take it to y equals mx plus b, take it to ax plus by equals c, whatever we want. Okay, so we can get it to the forms that we really want it in. So if we want slope in a point, because we can go from there to any equation that we want, that we are desiring, we're going to have to take those 2 points and come up with slope. So we would plug, okay, we can use either point, but this is what's missing. So we plug into the slope formula. M equals y2 minus y1 over x2 minus x1. You find the slope between the 2 points. And then you can use the slope and the point. So you'd plug the pieces into, then what we do just like usual is you'd plug the pieces into slope-intercept form, or into point-slope form. Y minus y1 equals m times x minus x1. So you'd use slope to get the slope that you want. Then you would have your slope and either of those points would work. Your first or your second point could be your xy. Just if you start with one, you got to finish with one. You can't mix and match the pieces here. Just pick a point and stick with it. And then you'd rearrange to have that ta-da moment to get what you want, that y equals mx plus b or the ax plus by equals c. Okay, and once again, how would you do that? If you want, this is the slope-intercept form, you would solve for y. If you want standard form, then you would move the x and y pieces to one side. You take the coefficients with them, with their coefficients, and then move the numbers to the other side. And that's how you'd get the ax plus by equals c. So that's our background then for, we tried one, we were given a point and a slope, and works great. You use point slope form and then you rearrange it to what you want. But it also comes in handy if all you have is 2 points. So from there you would have to do an additional step. Take those 2 points, find the slope. Once you have that slope, you can use either of those points, plug it into point slope form, and then do our rearranging like we've been practicing. So at the next video, we'll do a couple examples of that, and then you'll get a chance on your own try problems. See you there.